Next speaker is Navarro. And she is going to present a new approach, parameterization of cognitive disabilities. You will have more or less 20 minutes and 5 for discussion. 20-25.
Well, I'm Navarro, researcher from Ithaca, and I'm going to present this, the presentation is dealing with a new approach for parameterization of cognitive disabilities, specifically for Alzheimer, Parkinson, and cognitive aging. This is a shared work between Universidad Politécnica de Madrid and Ithaca, and it's under the 7th framework program project called Veritas. So, well, this is the topics of the study. I'm going to talk about the problem and the needs of this characterization of cognitive models. I'm going to talk a little bit about the user modeling methodology, about what we have called abstract cognitive user models, the actor research approach, that is cognitive architecture, a little bit about cognitive moderators, also called overlays, and I will briefly go through the results and conclusions. I have to say that it's an ongoing research, so many information is still ongoing. So what's the problem? As you all may know, we are aging, Europe is aging, the world is aging.
Come on.
So, yeah, I'm afraid we will, the population is going in just 20, 30 years, the percentage of population will be really old. So, as you can see here, we are, I don't know, I cannot see, but we are here. And in 2050, we'll have this percentage of people with aging. And what does it mean? It's going to have all this aging population. We have an increase in disabilities, physical disabilities, cognitive disabilities, problems with perception, hearing, speech, everything you can imagine that a person right now has already. So this will translate, of course, in a spending, in a huge spending on pensions and also the health systems. So what's the problem today? Okay, we have this problematic, and what happens with the applications, our services, the products, is not they are not universally accessible. So they hinder the user's autonomy. Okay? So here is the current process of design and development. This is the typical development chain with the designers, developers, with the user testing, typically with real users with no disabilities. And then if we want to design any product for automotive, smart living places, whatever, we make like a kind of patches between the products, the real products, and for disabled users. So we don't in fact create or design new products taking into account all the needs of every person in the world. We create specifically products with some accessibility aspects. And what's the aim of the objective of Veritas? Is trying to include in this chain, in the design and development chain, all users. An elderly, a person with a physical problem, a person with Alzheimer, any person that has a place in our society should be included in this chain, in this product chain. So, in order to create, to include this model inside, or let's say these people inside the product chain, we need to develop models that have all these characteristics of a person with a disability, with a physical, with a cognitive, or with a psychological disability, as you were explaining before. So we need to create, in order to facilitate all this process, virtual models that include these disabilities. How do we do that? This is the objective of Veritas. So we are trying to create, to develop like a platform, a framework for developers that would introduce simulation-based and virtual reality testing with these virtual user models, including all disabilities and other persons. The virtual users model generated will be based on existing metrics, standards, guidelines about users' capability. In fact, what is important here is not seeing a person with a disability as a disability. We need to focus on what a person with a disability is capable to do. It's not the disabilities, but the capabilities of a person with any disability. So this is I will go really fast through this. This is my methodology. This is created, done by Veritas. The methodology will be the same for physical models, for cognitive and psychological models. We create abstract user models, task models. We measure them, those missing parameters of values with the multisensorial platform. We generate the generic virtual models and integrate the three perspectives. I go really fast because here you can see it more clearly. On one hand, we model the tasks, what a person can perform in 5 domains. I think it's automotive, workplaces, smart living places, health domains. So we model the tasks that any person can do. This is the models. First with primitive tasks. What is a primitive task? A primitive task is like grasp or I don't know, a thought or a memory, or really the tiniest little task you can think of. Okay, and on the other hand, we model the users, the user models. First with the abstract, then the generic, and what do we do with the generic? We mix with the task models and the abstract. And finally, we create the virtual user models. Here you can see exactly what is, in the case of the abstract user model, it describes a general disability. A generic virtual user model, it mixes the abstract user model with the task model. So we will have a generic user, a group of a person, a people with disabilities. And then when we instantiate, we will have the virtual user model that is a single person with a single characteristic, with a single specific values. So, as I have explained, we will have three models. Physical, it's typical that we need to model functional disabilities, but maybe when coming to the cognitive problems or when coming to the psychological states, it's not that clear. And if we want to achieve universal accessibility, we should also focus on how to model these cognitive aspects and these psychological aspects. Why? Because really, a person with a cognitive disability, even if he can touch a thing, he cannot remember how to do it. This is in the case, for example, with Alzheimer or with Parkinson. In some stages, they completely forget how to do the easiest thing you can imagine. Or even with cognitive aging, you all see your grandparents losing some of the capabilities they usually or they used to have. So we need to model, we try to model all these things. This is what we included at the very beginning when we begin Veritas, the categories and the dimensions of the abstract user model with really abstract definition, types, what were the cognitive functional limitations and capabilities, the relevant parameters and metrics, and the computational modeling approaches that we found. So we had two main lines of research. On one hand, we have the definition on which were the relevant parameters, cognitive, or let's say better cognitive processes that matter in the context of cognitive disabilities in Alzheimer's, Parkinson, and so on. That would be the reaction time. A person with cognitive aging really slows down. The reaction time would be the memory, the attention, the perception, the decision making, and the speech. And also, on the other hand, we model and we try to see, in order to gain knowledge from the state of art, which were the existing computational models that existed for the 5 Veritas domains that I already mentioned. And we found out it was really difficult to do this and really challenging, because there are many and in different levels of development. And we found out that at the end, ACTA, it seems to be one of the most promising cognitive architectures. On the first hand, this is the first analysis that I was mentioning. We studied all the processes, the cognitive processes, perception, attention, memory, and so on, with the three disabilities, which were the level of, let's say, losing the capability for each one. Okay? And this is the main work of the first stage. And we will use this after that, and I will try to explain it. And on the other hand, the after research approach, after is a cognitive architecture that tries to model how a human person thinks. It's a modular organization, and the human thinking of this model emerges from the combination of the different interaction, the interaction of the different modules. This is the structure of ACTA. It's really simple. On one hand, we have the central processing of it would be the brain. We have here the perceptual system with the visual and aural. It does not include other perception systems, and the response. So basically, as is a little bit basic for the psychological expert, but what it does, it gets information from the environment with the perceptual system, of course, through vision and through aural. It gathers parameters that go to the central processing, the human brain as it happens, process information with some already memorized information that the person has in the procedural and declarative memory, and it gives an answer or a response through the response system, either motor or visual, back to the environment. This is basically after. It's a hybrid cognitive architecture because it mixes two kinds of structures. On one hand, it's in the top structure. It's like an if-then it's production systems that mainly explain how a person performs a task. And on the other hand, and what's really interesting in this case that I'm not going to lose focus. We are trying to extract parameters for representing cognitive disabilities. That it has a sub-symbolic structure. There are a set of functions with parameters that represent these previous processes that we detected in the previous step. So at the end, what ACTA does with these functions is represent attention, is represent perception, is represent memory, and integrated everything together. Okay? What is interesting about ACTA? It's interesting because it allows the customization of the situation. It has parameters, it has default values, but what it has also is the possibility of changing, tuning these parameters, these values, in order to reflect the cognitive disabilities of the models. We call it cognitive and behavioral models. What is a really clear example of what an overlay. It's caffeine. Caffeine is an overlay in our system. Why it modifies cognitive functioning. For example, in this case, it increases the processing speed by 3% and improves the vigilance by 30%. Well, I may need more than one copy to increase this vigilance in this, but okay, this is an example so you can more understand what's an overlay in cognition. So we have considered, in our case, disabilities and psychological states as overlays of ACTA parameters. So, as I was explaining, in ACTA and overlay, we modify the combination of parameters and mechanisms in order to represent the specific situation, acting changes to information processing. Okay. So, in Veritas, what we have done a research analysis in order to determine for a specific disability, which were the values for these parameters of the intrinsic equations of ACTA. We have conducted a literature research in order to extract these values and in order to create the second step, that was the cognitive generic visual user model with the ranges of parameters for all these disabilities, persons with disabilities. In a second step, we are relating the affective primitive task, as if you remember one of the first slides with the methodology, that we model also the primitive task. So we merge the affective primitive task with the ACTA cognitive parameters. So here it is, the generic virtual user model as it is now. We're still, it's an ongoing research and we are still finding some missing parameters. So we have here the values of ACTA, the intrinsic parameters of ACTA, and we have here the default value and the values we are founding for specific parameters. And in the third step, we added the affective primitive task relevant in this case for each one. As I was explaining, the ongoing research is focusing on developing these ACTA production task models that correspond to the task model previously defined in Veritas. And with all the information, we will create the parameterized cognitive user models. Until now, we have found 5 ACTA parameters related with cognitive aging, 12 ACTA parameters related with Alzheimer's disease, 5 with Parkinson, and the conclusions, well, we have, we believe that we will be able to use ACTA parameters to model these disabilities, this Alzheimer and so on. We have found parameters and values for most of the cognitive processes. We have also found we have tried to map many values, a lot of values from the psychological and medical studies, but we still need a lot of research in collaboration, of course, with psychologists in order to fill this table. Finally, additional research is currently being performed, analyzing also different psychological states and how these psychological states, stress, fatigue, emotions are also overlying the different cognitive processes. So we would like to, the truth is that we would like it to have it that clear, but it's not possible. A lot of research is still missing. We cannot still know which are the values and the areas of the brain. But I think we have some promising results, and I think it's quite well a research and a research that we are doing. Thanks a lot for do you have any questions? Okay. Yeah.
First of all, congratulations on your presentation. It was very clear. I'd like to know if is there any research going about behavioral modeling, maybe?
Yeah. We are performing in with the same methodology as I was explaining. We are creating also two models. One for physical conditions, mainly for people with less medullary lesions and injuries. And some arthrosis, and the other is for behavioral and psychological. We are modeling how, for instance, stress and different levels of stress have an effect on cognition, on the same processes. The truth is that the research also is throwing a lot of parameters and a lot of values, not only for cognition but for perception, for speech. A lot of research has been doing. I think the presentation of US, I have seen it, it's going to deal about it. And also, we are doing a lot of research in mental fatigue and motivation. But then this will be for the next presentation. I think for the next workshop. Okay. Any other question? No.
What kind of system, products or services can benefit from a design based on your product?
That's a really good question, and I'm sorry I didn't put it in the slide. Any product, the thing, well, maybe the most clear benefit is for interfaces, for graphical interfaces. I would put a really clear example. If you go to withdraw some money and the interface is not correctly done, maybe, I don't know if you remember that sometimes the card you take the money and you forgot the credit card in the withdrawal machines. And this is because the graphical user interface was not adapted to the cognitive situation, the cognitive processes. Because from the guidelines and from the models that we have seen, you should put in the last step, for instance, the goal that you want to achieve. So if you have a motivation, you have a goal, this should be the last one to put in, for example, in the graphical user interface. For instance, what we can propose here in the cases that the person does not remember a code. So a developer that is, for instance, testing one application with a complicated code could test the graphical user interface with an Alzheimer model and says, okay, my person is never going to use, a person with Alzheimer is never going to use this application. So why don't, what Veritas is going to offer is, why don't you use like a touch, like biometrical password. So instead of using a code that he has to remember, then he will say, please use in this case for this product, use a biometrical fingerprint, so we won't have this problem with a person with a cognitive disability. This would be an example.
Good example. Okay, thank you very much.